I'm so honored to be doing this panel because when I first got interested in how technology was pushing biology forward, the first three people that I discovered in this sort of revolution were George, arguably the most inventive and prolific bioengineer of our times, Josiah, who's got this totally punk kind of attitude about what the technology can do and who should have access to it, and Antonio, who's our extraordinary documentarian and investigative journalist who's tracking all of this. So this is kind of an extraordinary opportunity to get three people who've had a huge influence on me in a conversation all at the same time. So thanks for participating. And of course, we are here within the context of a documentary film that's being made called The Code of the Wild. And I think we're all dying with anticipation to see this film. And so we've actually had an extraordinary sense of luck because the filmmaker, Cody Sheehy, who's an Emmy award-winning filmmaker, followed George to China and was there at the Genome Editing Summit where J.K. Hay made his announcements. Antonio was able to break the story, and this was a moment that was all captured on film for the documentary, so that's all pretty exciting. And we have a special opportunity for everybody this morning. We are going to screen the first trailer for the film. So if we could roll the trailer, please. Which these guys haven't seen yet, so this will be there.
Imagine any characteristic in a human being and you want to modify it.
How long will I live now? I'm 51. Is there a chance that this gene therapy is going to extend my life, or is it only for people being born now?
Demonstrations in animals of aging reversal, so you can see a wide variety of biomarkers.
What I'm looking for is where gene editing is headed. And more the answer is China. I went to China to find out what was happening. It's a world of breadcrumbs.
This is how hard you
It's finding needles and stacks of needles. I mean, there's so much information.
He is what's left of investigative journalism.
He wants to tell a story.
I feel like he wants to tell a story.
This is part of our efforts to reverse aging in humans. So I've been involved for over a decade with companies in China.
People look to George Church. He's got gravitational pull in the genomics field.
There's kind of this public world, and then there's what's actually happening.
Is something I'm gonna do or is something I'm gonna sell gonna hurt somebody? I've never thought about it.
Anybody can use gene editing. I've been here for a week and I found 3 people editing human embryos. There's a cover-up. Babies whose genomes had been mutated as part of the international science race. When you press publish, you can't take it back.
Chinese researcher has created an international controversy over the world's first genetically edited babies.
Named Lulu and Nana.
Your story forced a conversation.
The accusation now is that you've broken the law.
I don't need credit for it, but I do need to be first.
As human beings, have never been able to decide what genes we get.
For this person, it's not dystopia. That's utopia.
So the biggest issue is just how quickly this technology is evolving. It is breathtaking.
Right? So, can't wait to see that. So the filmmakers are actually here. Cody Sheehy and his producer on the documentary is a CRISPR scientist named Samira Kiani. She's an assistant professor at Arizona State University. And her research interests include all the various types of gene editing, including CRISPR, and also using synthetic biology for human genetic therapies. So they're here. They're still filming. The movie has not yet been finally edited, and so I don't have a release date for you. Do we have a release date this fall? No? Yeah. OK. So to be continued. It's called Code of the Wild, and I think it's going to be great. So for those of you who were here this morning, you heard a lot from George about what the current state of genetic editing is. But just to back up for a minute, and for those who were not, and for those, by the way, who might be live streaming this, George is a Harvard PhD. He's got a PhD in biochemistry and one in molecular biology. He's on the faculty at MIT as well as Harvard. He's a founding member of the Wyss Institute for Biological Design, which is super cool if you haven't checked that out. He's been a pioneer in genomic sequencing, genome editing, the founder of the Personal Genome Project, which was an effort back in 2005, an ongoing effort that encourages people to donate their genome for research purposes in the public domain. There's the Human Genome Project Right, which we want to talk about a little bit today. He's been at the forefront of human germline genetic editing, engineering, human enhancement, xenotransplantation, anti-aging research, dream drives, and space genetics. So he's a busy man. His conflict of interest page is extremely long. How many slides does it take to? Do you get it all in one slide? Of course, because he likes everything as small as possible, so he can have the maximum amount of information. But includes companies involved in genomic sequencing, consumer and clinical genomic diagnostics, brain-computer interfaces, synthetic biology, stem cells and therapeutics, publishing and nonprofits, and the list goes on and on. He's published over 400 papers. I asked you, I think last year, how many companies you had started, and wasn't it like 22?
I've co-founded 25.
25.
But I've helped a few others.
Yeah. George is a man of enormous capacity. So I kind of think of you as a national treasure, actually. And certainly the most inventive bioengineer. And you're incredibly generous with your time, your genome, your data sets, and also your advice. He says, I particularly like to give advice to people who need it. So that's great. Josiah has master's in molecular biology, PhD from the University of Chicago in biochemistry. He's worked as a security analyst, a computer security analyst, an astrobiologist at NASA, working on synthetic biology solutions for recycling and terraforming Mars. He's the founder and CEO of a company called The Odin, which, as you describe it, is the first and only consumer genetic engineering company. So you sell CRISPR kits and gene editing supplies to consumers, and increasingly to educators, right? Okay. So Josiah's our provocateur. He's the one who's trying this stuff out, kind of punching out the boundaries of this world that we're building and seeing where it all goes. And then Antonio, as the biomedicine editor at the MIT Tech Review, he's been a business editor. He's worked at Science Magazine in Latin America. He's been a foreign correspondent in Brazil for the Wall Street Journal. He's got an undergraduate degree from Yale in physics and a master's in science and medical journalism. So he's really the go-to source of information about leading developments in this field and has clearly identified himself as the reliable source, the person who's going to get the story first and he's going to get it right. So I want to talk first about the biotech revolution writ large and where we are today, what we can do, what people are doing today. Then we'll talk a little bit more specifically about human genome editing and what people are doing with CRISPR. And then I'd like to talk mostly about the future and what these three people think the future has in store for us. And I also want to leave some time for a couple of questions from the audience. And I see we have a full house here today, and I know everyone has questions about where this technology is going to drive us. So if you want to think about your questions and send them in, they'll be upvoted on the Slido app, and they'll pop up here, and we'll leave some time for questions at the end. So let's get started. Whenever you talk about biotechnology and the revolution, there's this famous slide that the National Institutes of Health generated, where it shows Moore's law, which shows that the power of computer transistors and chips would double every 2 years, while the price would be cut in half. And so that makes this extraordinary looking trend line on the graph. And then below that is the cost of genomic sequencing, which is tracking along at $100,000. Well, it starts at $3 billion, then it comes down to $100 million, and then it gets down to about 25,000, and then it just falls off the cliff about 2007, when next generation genetic sequencing was invented, which George, of course, was deeply involved with. And so that implies that the innovation response to those dynamics could be multitudes greater than the innovation that's followed because of Moore's law. So let's just start with that. Can the genomic and biological innovation exceed the innovation that we have seen with Moore's law?
It can, and it can even impact as Moore's law starts to plateau in its ability to make smaller and smaller circuit elements. We get to a range where you might want to make atomically precise electronics, and biology has a long history of making atomically precise objects, both organic and inorganic chemistry. So I think it could directly contribute to computing. It already is responsible for the most amazing computers in the world, which are inside of 7 billion human skulls. But it also, just anything that you want, any material or any chemical, green chemistry, is now suddenly much more accessible because of these exponentials, not just in reading the genomes, where we can harvest billions of years of evolution, but writing the genome so we can see what it means and engineer it forward.
Mm-hmm. So, Antonio, coming from MIT Tech Review, you're very focused on engineering and computing, and I'm just curious to what extent that you see us being able to use biology in the same kind of plug-and-play way that we've been able to do with computing. Do you see these analogies? Are they?
I do. I mean, we're our technology magazine, and I cover science or biology, as a technology. So that's why I pay a lot of attention to George Church, who's kind of developing these new methods, CRISPR being the most important, and also then Josiah, who's kind of throwing them out there to the world. The plug-and-play analogy, the analogy that DNA is just a code, very popular in Silicon Valley. I think a lot of people would like to use biology the same way they use computers, to make piles of money, to change the world. I don't know how far the analogy holds up.
Have you seen limits already?
Sure. I mean, the scientists can speak to it, but I don't think biology behaves like a computer code necessarily that, you can control it and get the exact answer that you want.
Mm-hmm. Because you were saying, biology is incredibly precise. Isn't it messy and unpredictable?
Well, it's you can make it less messy and less unpredictable, more predictable by taking the parts of it that work particularly well for particular applications. So you can go far beyond what nature does for human applications. I think it doesn't work like computers. I agree with Antonio on that. In certain ways, it has advantages. So, for example, when you build a prototype cell phone, you don't make 1 trillion of them, but in biology you can. You can make 1 trillion prototypes, and then you can have clever ways that they self-select for what you want. So, not to mention that you've got incredibly sophisticated devices that have already gone through 3 billion years of trial and error that has the semblance of looking like engineering. So it's just an amazing gift that we have. We just have to go out there and find, just lying there in the dirt is the next CRISPR.
Mm-hmm. But in terms of coming up with computer programs that we can basically plug and play in the same way that you don't have to understand how a computer works today to actually run a computer, right? You don't understand TCP/IP protocols to use the internet. You know, will we get to a place where our biological tools will enable us to basically have a graphic user interface where we can sort of...
Oh, we're way beyond that. Plug and play started in the 1500s. I mean, so smallpox vaccines, we had no clue as to how immunology or virology worked, but we made this incredibly effective medicine that's the first technology that is $0 for 7.5 billion people. Everybody on the planet is now protected because it's extinct. So we did that extinction without having a clue what we were doing. So plug and play, we beat electronics.
Great, okay. That's great. So you have been at the forefront of the Human Genome Read effort. And about 2 years ago, is that right? About 2 years ago, sort of announced this initiative, which is Human Genome Write. What can you tell us about what it's going to take to create a synthetic genome?
Well, to some extent, that 2 years ago was just a recognition of what was already going on. Jeff Bouquet had a consortium of groups all over the world that were working on synthesizing yeast, and my lab had a much smaller group that was working on the industrial microorganism E. coli. And we just said, oh, those projects are going so fast, why don't we just broaden it to all other organisms and technology development? Because we watched these exponential that you mentioned, the faster than Moore's law reduction in reading costs and writing of raw DNA. We wanted to bring down the third, which is assembly and testing of DNA. So Genome Project Write is really about assembling big genomes that are radically different from naturally occurring genomes and then testing them efficiently. And so we're aimed at plants and animals and human cells for manufacturing and making them virus resistant.
So you're not trying to create a synthetic human?
Human cells could be used for transplants. So if you consider that a synthetic human, then yes, but nothing beyond that.
Yeah, there's a novelist, right? Murakami, was it Murakami, wrote a book about growing clones to harvest their genes?
Yeah.
And that was considered highly unethical, so this would be just growing synthetic.
So we have lots of copies of my cells growing in many labs around the world from my body, but that doesn't mean we've cloned me. It's just they're convenient resources for making organoids, which are not yet transplantable, but they are useful for testing new therapies, for example. And we can do the same thing for other people that are properly consented.
So you and Henrietta Lacks. Are there more George Church cells out there or Henrietta Lacks cells?
I doubt it, but it would be a nice thing. Right now we're wondering when there'll be more cells outside of my body than inside my body.
That's great. That's great. So that's sort of alarming to a lot of people. But I'm curious, Antonio, what do you think is going to be the biggest story in 2019 in this space?
The big story of 2019?
Yeah.
If I knew it, I'm not sure I'd say it here because got to write it first. Hopefully George will tell me, or Josiah will. I've been peppering them with questions. What's the big story? I don't know. I've heard lots of interesting ideas thrown around in labs, and it's really hard to predict what the next story will be. We might have further shoes to drop on this whole CRISPR babies story. I don't think we know all the facts. We may not know whether there's sort of other programs to make genetically modified people that are out there that are not yet disclosed. So that's something to look forward to or to look out for.
Okay, cool. So let's see. I have my pages. I have a question for Josiah here. Let me just find it. Okay, so Josiah, you have been known for doing some pretty radical things with this technology. So the first time I heard about you, you had done your own fecal transplant. Then you were doing, making your skin cells glow, or trying to make your skin cells glow. I'm not sure you pulled that off. And then I actually saw you inject a plasmid with a myostatin knockout, which, if it worked, would have allowed your musculature to continue growing. So I guess the big question I have for you is, what is your role in this neobiological revolution?
Yeah.
Why do you do what you do?
I kind of see myself as an activist and an advocate. If you ask somebody right now, could you buy a kit online, have it shipped to France or China or someplace in the US, where you could do genetic engineering, where you could use CRISPR, most people would have no idea. They would be like, that exists? I can do that in my home? It's not illegal? In some countries in the EU, it is illegal. But it does exist, and people don't know about it, and that's crazy. We know more about computers than we know about our DNA, and our DNA is what makes us. To me, that's crazy, right? And we have the system set up where science and medical knowledge are put away so we can't access it. You have to pay to read government-funded knowledge. Knowledge is only available to those who can afford it. How do we make this available to everybody, right? I'm a big advocate of self-experimentation, of gaining knowledge and doing things to push science forward and trying to get around the system, because the question isn't anymore, how are they going to regulate us? It's how are they going to stop us? We've been doing gene therapy on humans since the late 90s. We know it works. We know you can modify humans. This isn't something that people should question anymore. It works, right? So the question is more, what are we going to do with it? What do you want to do with it, and how are you going to use it? And that's what I want to tell people. That's what I want to let people know. That's what I want people to do. Modify yourself.
Okay. 4 people agree with you.
Thank you for that.
So would you call yourself basically an optimist about human nature? Do you think people will generally use this technology for good?
I'm not an optimist. I just think it's a human right. Body autonomy. We should be able to do what we want with ourselves. We should have access to medical treatments, right? We're not concerned about the people who are dying right now. We're concerned about the people that we might hurt, these hypothetical people. And not enough people are concerned about everybody who's suffering and dying right now. And I think, what are we going to do about that? What are you going to do about that? Right?
And so by concern, you mean things are priced out of the range of many people?
Everything. Here's the thing. 2015, Glybera, the first gene therapy approved in the EU. They tried to sell it for $1 million. It treats a disease called lipoprotein lipase deficiency, LPLD. About 30 people got it. Nobody bought the gene therapy, so they took it off the market. There's literally a cure for a disease using gene therapy that's out there that's not available. And you know what? I read through the regulatory filings, the patents, and the papers. You can reverse engineer that. I can do gene therapy piracy, provide that to you for a couple $1,000s to cure your disease. Why is nobody doing this? Why is there a treatment for gene therapy that went through a clinical trial, was approved, is not available? That blows my mind.
Okay. So let's talk about the biohacker community, right? Because there's people out there who, for instance, think it's unconscionable to have to spend $7,000 for insulin, for instance. And so they are creating insulin in their labs. It's not something that has scaled up, but what do you think about that? Is that the kind of thing that biohackers should be doing? Antonio, what do you think?
Well, I don't think they've done it yet, which is interesting. I mean, the production of insulin in the laboratory, human insulin was kind of the beginning of the biotech era, the 1970s. And so it's interesting to see a group, I think in California, they have an open insulin project to try and repeat those first steps. So to me, it's most interesting just as a kind of a measure of where the do-it-yourself community is. I mean, can they repeat the first act of biotechnology? It's not so easy to do. Should insulin be priced at a lower price? Yeah, probably. It's incredible that it isn't. And
What about
Yeah.
the EpiPen? What's the status of people trying to reverse engineer the EpiPen? So you don't
The EpiPen. I really don't know. I haven't seen these reverse engineering projects actually work yet, but they might. And certainly, I mean, you'd think that there could be a hospital, a nonprofit, or a citizen group that could, if they could really produce insulin and supply it, that would be exciting and a big change.
What do you think holds people back from being able to accomplish these things?
Well, some people say it's the tacit knowledge that you gain when you work in a lab. You're one of George's PhD students, or you work at NASA, and then you develop all this tacit knowledge about how the biology actually works and how to actually do the experiments. And if you try and climb that mountain without that prior experience, you don't make it to the top.
Do you worry about the purity of any drugs that might be created in the lab?
Well, we're speaking.
I worry about the purity of the drugs that get approved by the FDA. What is it, just Volstartin got recalled?
Okay, fair enough.
Well, let me just jump in. I mean, there's this discussion as if the FDA, which is the US regulator of drugs, is hiding all these treatments. Like there's all these treatments that could be but aren't available because of some kind of state conspiracy or something. I don't think that that's true, and I think that if you say, well, let everybody do gene therapy on themselves, you've automatically pretty much thrown out the whole question of evidence, right? You need evidence to prove something works. I don't want to buy a drug. I don't want to take a drug that doesn't have evidence behind it.
Right.
So by their nature, so far, the do-it-yourself experiments, including Josiah's self-injection of DNA plasmids, of gene therapies. I mean, George mentioned they're sort of N of 1 experiments, right? It's one person, so it doesn't generate necessarily the kind of evidence that you'd want before you take a drug or you sign up your kid to take that drug.
Your mileage may
So
vary.
I'm less eager to knock down the edifice of regulation.
Josiah, in the film you say you've never thought about whether the stuff that you sell could be used, if people could hurt themselves with the stuff that you sell. Do you think that your exploits have encouraged people to take unreasonable risks?
Oh, yeah. I mean, I hurt myself eating dinner last night with a fork, so. But that's just me. I struggle sometimes. A little too much wine. I think that instead of focusing on all the negatives that could happen, we should focus on the positives. If you look at automobiles, we sacrifice 1 million lives a year to the automobile gods. And if you ask one person whether they would get rid of automobiles, nobody would say no. Nobody would. I mean, you might have that one, hipster person who would be like, yeah, no automobiles, let's outlaw them all. But in general...
I think the mayor of Paris would agree with you.
In general, we're going to keep automobiles. And I think we have a distorted risk analysis when it comes to medicine because we're always worried about the people who could get hurt, and we're not worried about the people who are dying now, right? People who are suffering now. And I get so many emails from so many people, and I'm sure you do also, George, who people are just asking you and begging you for help. Can you help me? I'm dying. Can you help me? I'm dying. There's no treatment. And I think there comes a place where we have to say, how many lives are we willing to risk to help the millions of people with muscular dystrophy? Is it greater than 1? Maybe. Is it greater than 10? Maybe. But we have to make that decision. We have to come to that conclusion and decide we need to be riskier. We need to push drugs faster through these clinical trials. We need to save more lives as quick as we can. And, if it's risky and people are encouraged to do risky things because of what I do, it sucks. I don't want anybody to get hurt and die. But also I want to see stuff move forward fast so people can get help.
So, George, you've been kind of the... I think in many ways the patron saint of biohackers. I mean, encouraging people to explore their curiosity and to explore what the technology can do and to imagine and push this forward. But you got in a bit of a row with the biohacking community when you said anybody working on gene editing should be under surveillance.
Right. So, yes, I was an early proponent of DIY bio in Boston and New York and San Francisco, and was there at some of their openings. And, but the comment about surveillance was not directed at biohackers so much as all of us. The analogy is with driving. So you get a driver's license, but that's not sufficient. Getting a driver's license and having a lot of laws is not sufficient. You need to have radar, you need to have little alcohol testers, you need to have evidence that they're the right age. So there is surveillance on the road, and I think that the power that you possess when you become a synthetic biologist, whether you get it from a kit or whether you go through a long PhD and postdoctoral training, that power is at least comparable to the power you have in a car. And so there should be licensing and surveillance. To me, that's not controversial. And I think once that was explained to my friends in the DIY community, they were very supportive of it. I think they've been, from the very beginning, very proactive on safety and security. So I'm a big supporter of that community. Yeah.
Great, great. Okay, so we can't really talk too much about this without going straight at longevity. So George, you've got a lot of projects underway in both mice and dogs, I believe.
Right.
Where are you with that? How soon can we hope to live well beyond, let's say, 100 or 125?
So I think it divides itself up into kind of three categories. One is doing what you can with lifestyle, and I think many of us are already doing that. So that's kind of the baseline, eating well and exercise. Then the next level up are relatively easy, generally recognized as safe compounds that are reformulated to be of medical grade. So like Elysium basis is an example of one of those, which is going through, even though it's a nutritional supplement and you can provide it without FDA approval, it is going through randomized clinical trials on a fairly large scale to see that it actually has things like aging reversal effects in humans, so human clinical trials. And then the next level up are really serious medicines that you would not take lightly, like gene therapies, which we're starting in dogs simply because people care deeply about dogs, and also it gets us lots of effectively phase 4 clinical trials with a veterinary product with animals that live in a human environment. So they're a very good model, much better than mice would be, or even primates. So anyway, that's Rejuvenate Bio that's doing that, and we've already got one, and we're using combination gene therapies based on genes that are very well established in a variety of animal models. We're turning them into gene therapies that can be delivered at fairly low doses, and we're trying to get people used to the idea of low cost as well. So the cost for the dogs will be probably in the $1,000 range rather than $1 million, which I agree with Josiah is a non-starter for equitable distribution of medicine, which is really should be one of our top ethical concerns, is that everybody gets access to safe and effective drugs.
So we're going to go quickly because I have 2 more surprises for you guys. What's your longevity hack, George?
Hack?
Yeah, what do you do to maximize your...
Well, I don't randomize clinical trials.
Okay. Good answer.
I'm a big proponent of doing things the right way. I'm willing to participate in them, and I have participated in the Elysium product, and will in the Rejuvenate product when it makes it through the dog trial.
You will do a gene therapy on yourself.
I would consider it if it makes it, yeah, if it's in approved clinical trials. Yeah, I mean, I am vegan for what it's worth. I mean, for me, that was a better hack than statins. It worked better than statins for me. So, yeah.
Okay, Josiah, what are you doing to live as long as possible? First of all, is that a goal for you? And secondly, what do you do?
Scotch and Captain Crunch separately, not together. I've never really wanted to live. I used to watch Highlander a lot as a kid, you know, and Queen had that song "Who Wants to Live Forever." I never really wanted to live forever because I didn't think I would ever live forever.
Okay, Antonio, what are you doing?
Longevity, I mean, is definitely, I feel skeptical when I hear those claims. On the other hand, sometimes you could see evidence of it. You know, people clone dogs. Talking about dogs, you clone a dog, the dog dies, you make a clone. That's longevity for that genome, right? You've doubled the life of that genome. So
that's your strategy, is cloning, self-cloning. Okay, great.
Exactly.
All right, we've got another clip to play. I think you guys are going to love this one. So let's see if we can get the next one up.
Another clip.
So I give a little background. Oh, here we go. Okay.
Right now we are in the second International Summit of Human Genome Editing in Hong Kong. Basically, we are waiting for Dr. J.K. Hayes' talk.
I would like to, if you can hear me, ask Jungkook Hay to come to the stage.
First, I'll give an overview of our data, focus on human and monkeys.
They obtained about 30 eggs from these 7 couples, and they actually impregnated one couple with 2 embryos, edited embryos, and now we have a twin girl, Nana and Lulu, that are born.
The general feeling amongst the scientific community is that we shouldn't go ahead yet in doing this.
I personally don't think that it was medically necessary. I still think that unless and until the safety issues have been dealt with and this broad societal consensus would be considered irresponsible.
So, of course, his announcement was met with widespread horror and an immediate outpouring of frustration by the scientific community. But George, you were one of the lone voices to defend him. I think a lot of subsequent information has come out about, or questions have come out about it. You know, was he addressing an unmet medical need? Did the people participating in that actually have truly informed and meaningful consent? And is the data valid? And did he execute well? So, in fact, Feng Zhang famously said that he didn't actually share, even though he consulted with scientists, he didn't actually share his intentions with Feng Zhang after he criticized him for his technique. So I'm just curious, do you still defend J.K. Hayes' actions?
I didn't defend him so much as say that there should be a balanced discussion and there should be a focusing on the data. So many of the reactions occurred before anybody had seen it. In fact, they still haven't seen the data. I had access to the data prior to the meeting.
Did you know what he had done?
I did. So there were 2 papers that were provided to me by the Associated Press. So I felt that I met my responsibility of communicating with the public the threat. While there were other people who knew that he was doing it, they didn't have access to data, but they knew he was doing it, they did not report, did not feel a desire or a need to report what he was doing. And I think that was the failure of the system. It was not that we didn't have we had a moratorium, we even had laws and consequences, but everybody was ignoring them, but not just the scientist. Mm-hmm. In terms of the critique, you know, seeing the data does change one's attitude, I think. He did an extensive number of experiments on primates with implantation and with human without implantation. And I think that, and to say that there was no need for it, or there was already a way of dealing with it with HIV, I think is a great oversimplification. 1 million people die every year from HIV. It's 2% of human deaths on Earth. To say that we have a solution like safe sex or antiretroviral therapies is an oversimplification. But it's also naive to say that this particular method is going to make a big dent in it, but it could. It's a little hard to predict something that's so early stage. I just felt that we needed a balanced discussion of what was going on.
Do you feel that his work has set the field back or advanced
I think it's
it?
too early to say. I mean, for example, people were very concerned in vitro fertilization in 1978 that Louise Brown's birth might set the field back, and it would have if she had been born, you know, teratomic, you know, with all sorts of deformities. And it didn't. It set it forward because people shouldn't have been drawing negative or positive conclusions from an N of 1, but they did. They got very excited about the fact that she was healthy, and she went on to have children of her own. But the field was set back in the year 2000 with gene therapy, where 3 people died in 2 different studies. So I think it could set it back, but not necessarily because he didn't do the consenting exactly the way everybody else would have done it. He did get approval, and he did it in such a way. If he had done more, if he'd done everything that all the critics wanted him to do, I am pretty sure that we would know the name of the family at this point. Antonio would have told us the name of the family by now if there were a trail of breadcrumbs leading to that family. And so you have to acknowledge that he did cover for the family.
CCR5, knocking it out can help prevent HIV.
Yeah.
Excuse me. But it can also enhance our cognition.
I mean, I don't think that the...
Is this a front for a brain enhancement experiment?
It is a form of enhancement. I mean, I think one of the critiques of why would you do the experiment is that the medical need for gene editing of human embryos and making people is not that great, or it's not clear where it is. There might be some sort of very narrow cases where it's medically required. Yet it's interesting technology that could work, so it kind of very quickly opens this horizon of enhancement. I think trying to make someone immune or resistant to HIV is an enhancement. Just like getting a vaccine, someone mentioned smallpox vaccine, that's also an enhancement. So very quickly, and it's interesting, you know, the first case is already an enhancement case. So I think that's where the conversation goes. You know, what kind of enhancements could we get, and do we want? There could be enhancements. George has a kind of a whole list of genes.
That's right. Let's talk about that.
You know, there's one that I wouldn't mind having, which is protection against cognitive decline. I don't know what cost that particular gene mutation has, but there are people out there who they found them in Iceland. You know, if you have a specific mutation in a specific gene, people live, you know, with clear minds until the end of their lives. And I think, you know, in our society where people live longer and longer, you know, that's a kind of enhancement that one would seriously consider, just given even the cost of caring for old people and that kind of thing.
And those enhancements could be done in adults, not just in embryos. So I think when we entangle those, we're unnecessarily giving reassurance that if we block the embryos and we block enhancement, that's just not true.
So Josiah, you talk mostly about enhancing ourselves, right? Is that where you see this going? Are you more comfortable with that kind of an approach? Or what is your take on human embryo editing?
Well, it's more like what is a medical disease or what requires medical treatment? If I am, 3 feet tall, is that a medical condition? If I'm 3 foot 6 inches tall, is that a medical condition? 4 foot, 4 foot 6 inches, 5 foot, like where do you draw the line? I don't think you can draw the line. And where you can't draw a line between a medical condition and an enhancement, I think that we shouldn't be worrying about what is a medical condition and what is an enhancement. What we should be worrying about is how do we get everybody access to this technology, right? The only reason we're worried about enhancements is because we're afraid that the people who can afford them are going to get all these enhancements and the people who can't afford them aren't. And it's going to create a huge class distortion. Well, if we come into it like George said, and we try to make this stuff affordable. If we start from the bottom and say, let's focus on access. Why is nobody talking about access? All people are talking about is, how do we outlaw this? How do we do this and do that? There's 40 countries in the world with no medical regulatory body. You can't stop this. Nobody can stop this. We need to focus on access to people, making it affordable, and giving it to everybody, and then we could have any other conversation you want.
I think those four... I think most of those 40 countries with no medical regulations also have at this point, no capacity to do that much science. People from elsewhere.
That's not true. Dominican Republic, there's a lot of places that are industrialized that you can do science perfectly well.
The Dominican Republic has no regulations?
Yeah,
okay. Well,
no medical regulatory body.
I've been there and it didn't sound like it, but I mean, last week we had a call for a moratorium on creation of more genetically modified people from a bunch of senior scientists around the world. And so I think the discussion, I mean, just in contrast to what you're saying, Josiah, the contrast is actually about more government control. That's where that conversation is today, this week. It could change. So there's these different currents. And a lot of people, not George, but other people in the scientific community, I think they're kind of calling in the regulators and the governments to, put the screws on this.
How do you stop it though, right? Like I could order this stuff to my house. I could order a microinjector on eBay. Companies do single cell sequencing for me, right? The only thing I need is somebody to retrieve embryos, get sperm, and do the implantation. Like, how do you stop
that's
it?
a licensed medical professional who may have their own concerns. It's a doctor. Can you convince a doctor to do it? It's not even clear in China if the IVF people exactly knew what was going on. But George may have more thoughts on control mechanisms if we need them. And
I think we have perfectly adequate mechanisms for getting safety and efficacy. The EMA in Europe, the FDA in the United States, CFDA in China. What we don't really have are good surveillance methods, and the moratorium is not an effective idea. We called for a moratorium in 2015, the Baltimore et al. Science paper, and this Nature paper is almost exactly the same thing, and it is proven to be ineffective because we don't need a moratorium which is sort of voluntary and non-binding. We have laws and we have penalties. They just need to be enforced, and scientists who know about it need to speak up, or they need to be encouraged either positively, either via penalties or via enticements to report what they're seeing. That was what was failing. It was not a failure to have a moratorium. We've had a moratorium for all new therapies. What we need is surveillance and enforcement, if we care about it.
So you think existing FDA-type or EMA-type organizations within each country should be adequate to keep track of what's happening within their national borders?
Well, they're more adequate than a moratorium because they actually have laws that will punish people for doing drug development without permission. But if we need something new, it is not a moratorium. It is stronger encouragement for people to report what they're seeing.
Okay. So are we evolving ourselves now in real time? Are we changing Homo sapiens?
Oh, well, we're not, yes, we've been doing it for a long time, and we're transhuman in a certain sense, in that our ancestors would not have a clue as to what we're doing, why we care so deeply about cell phones or Mars colonies or conversations in front of cameras about vaccines and things like that. And you could say, oh, that's not heritable, but it is most certainly heritable. This object is more likely to be inherited than my genes in my offspring. So I think we have this weird double standard where all sorts of heritable technologies that are not involving DNA are treated differently than things that are. and they should be subject to randomized clinical trials as well. In fact, they are. Medical devices are, but you know, this thing here is possibly more revolutionary and disruptive to our health than a typical medical device.
So, but you're talking about this list of genes that could be used to create spacefaring humans, right? There's a whole long list to give.
Or even humans on Earth, right? I mean, this is a list that I've been maintaining for years of human beings, or in some cases mice, but mostly human beings that are walking around that are already living experiments for whether a new drug would work or new gene therapy would work, because they basically, from birth, and all their offspring inherit this, and they're fine. And in fact, they're better than fine with certain respect. They might be resistant to the norovirus, stomach flu. In fact, they're members of.
But I'm trying to get you to think much further out. I mean, Josiah, you said when you were in college, all your techie friends were talking about, you know, robots and flying cars, and you know, they're all doing robots and flying cars, and you were talking about dragons, and you're still not doing dragons. So, should we be doing dragons? Should we be doing spacefaring humans?
I think humans evolve really slow. Social evolution is really interesting because that evolves really fast, right? So social ideas can change the way we act in years, where, you know, genetic evolution takes generations. And I think in order for all of this to really go forward and the genetic engineering revolution to happen, it's going to be a social thing. So people like Antonio writing stories, your company Neolife doing stuff, George and myself being advocates and activists and yelling and saying, hey, pay attention to this, because there's nothing stopping human genetic engineering from happening. As we saw what happened, it's just more the money needs to be put into it, and people need to be socially accepting of it. And then once those two things happen, the revolution is here.
So in France, you can't, correct me if I'm wrong about this, but I think you can't currently order a 23andMe test online and have it delivered to your home in France. I believe that is the case, yes. You know, the Chinese scientist at the CRISPR meeting, you know, famously expressed a completely different point of view about the viability of a deaf fetus, right? Deaf Americans welcome more deaf American children into the deaf community. In China, that's considered a less viable human, actually. So when you think about moving forward, you know, the Chinese and the Indians will have potentially a far greater influence on these choices that we make as a species than the FDA or a European regulatory industry. So when you look forward, thinking about this, whose morals and whose culture will dictate where we go?
Well, I think we're much more convergent and in alignment than it may seem. And I think what happens is we do small experiments, they're not gigantic ones, that are slightly divergent, and then we see how it turns out, and then there's broad acceptance of the best practices. And I think that will probably occur with almost every new technology we're talking about. A few of them will be rejected, either because they're uneconomic or they're hazards. You know, like jetpacks, for example, are not a thing, not because there was a moratorium on jetpacks, but because they simply just didn't work. They were not cost-effective or safe enough. So I think that the same thing happened. If anything, we're going to be too homogeneous across the planet. Diversity is a good thing for generating and testing new ideas, but...
You're worried about us becoming more homogeneous?
Yes, if we become a monoculture, we become at risk for change. If everything is constant, monocultures are good, but we need to have, we have social, technological, and biotechnological evolution going on at a very high rate. And I agree that my critique of germline is not the usual. It's that it takes way too long, and there are other more cost-effective ways of doing the same thing.
So Antonio, I know that as a journalist, your training is to report on what happens and less about, prognostications about the future and perhaps less about our moral and ethical choices and dilemmas, but how do you feel about tinkering with our species, you know?
Right, I cover the tinkerers. I think I'm trying to follow the new technology to its sort of most controversial use, where it becomes interesting to talk about. Sometimes it's at Josiah's place if he's selling kits, sometimes it's in George's lab. I mean, you know, these are the kind of focal points to draw our attention. How do I feel about tinkering with it? I mean, my typical answer is that it's sort of the oldest story of all the stories and all the myths. You know, anybody, you know, trying to be like God is sure to run into a bunch of trouble. Do you know what I mean? It's kind of the oldest myth of them all. So, is it bad or good? I don't know.
Interesting. Okay, so what about that, George? Is this arrogance, technological arrogance on our part, is trying to overcome disease, trying to extend lifespan, trying to create animals in a petri dish, trying to come up with clean energy sources, create synthetic genomes? Are these things godlike powers that we're going to fly too close to the sun?
Well, I think the metaphors with, flying too close to the sun, that's why we have regulatory agencies. It only becomes arrogant and laughable or sad if we ignore or try to get around our regulatory agencies. We should strengthen them. We should enable them to go quickly and to help us reduce the costs for equitable distribution. But we shouldn't sacrifice too much on safety. Clinical trials do involve, and new helicopters and all kinds of things do involve loss of human life, but it's very unfortunate. We should try to minimize that. And I think as our technologies get better, loss of life is less and less likely to occur. And that has to be one of our top priorities is safety engineering. We should get very, very good at that.
So we've just seen this scandal explode in the United States about the lengths parents will go to get their children into desirable schools. Do you believe that regulatory agencies should be responsible for making sure that we have a level playing field?
Well, yeah, so that's not their, maybe they should be, but that's not, right now it's safety and efficacy, it's not really cost or equitable distribution. I think we as a society should be responsible for that, and sometimes the companies, the academics and the companies that help bring down the costs are rewarded for that. Certainly bringing down the cost of DNA sequencing has been rewarding for many people involved. And I think that hopefully the same thing will happen with radical reduction in therapeutic costs. Mm-hmm. Certainly there are some things like vaccines that are extremely cost effective already.
What do you guys think? Is this, Antonio or Josiah, what do you think? Is there a way for this technology? The future is famously inequitably distributed. The future comes first to those with means.
Exactly. No, William Gibson, right? He said, the future is already here. It's just not evenly distributed. And it's so the truth. Like, it's just not distributed to us all. Everybody doesn't have access to it. And so giving people access to the technology, decentralizing scientific knowledge and education, medical knowledge and education, access to medical and scientific tools, I think that's what's going to bring the future to us socially. That's a social thing. And then once that's here, the future will be here for everybody.
There was a poll in the United States by the Pew Organization, and they do an ongoing poll about people's feelings about designer babies or genetically modified babies. And in the most recent issue of their poll, they asked people sort of what was their top reason for concern. And it wasn't kind of moral outrage. It was that it wouldn't be equally distributed. Like, their main concern would be sort of, the wealthy get it and the others don't. So I thought that was pretty interesting in itself.
Any last thoughts on what we are becoming? What do we want to become? If we're taking control of our own evolution.
Are we getting better or worse?
Obviously better, I think, socially, health, medical, scientifically, yeah.
I think we have amazing technologies that are getting exponentially better. We have a dedication to safety that's unparalleled in history, and the safest thing that we can do is to get some of us off the planet. We need a backup, and so we finally have the technology and hopefully the good sense to do that carefully.
So how long do you think it's going to take to engineer a spacefaring? To engineer a spacefaring?
We may not.
I was going to say human, and then I was going to say Homo sapien, and then I don't know what to call it.
Well, I think
because they're probably not going to be able to reproduce, so it would have to be a different species.
I think we're going to be traveling long before we have time to do this in the germline. It's quite possible that we'll be doing this through somatic gene therapy, and that could happen. The clinical trials on that could include people going into space. So it could be that that's happening simultaneously, and that could happen within the next couple of decades.
Within your lifetime?
Yes. Well, if we do aging reversal, that's not a big limitation, but yes, hopefully within our lifetime.
Amazing. So we have one final clip for you guys. Let's roll the last clip from the film.
I think it's just one of the most exciting times to be alive. The way we make babies today, that's going to become pretty archaic.
Human beings have never been able to decide what genes we get. We've never got to decide any of those things. Let's just imagine a future. Now you have a choice. Here are your choices of the person you can be. I don't know, it gives me goosebumps.
It's their children. They got to do what's best for their child. You can see how somebody who wouldn't want to be part of a world in which this was possible would nevertheless feel an obligation to take advantage of it. I reject the discourse of inevitability.
Great.
All right, thank you.
Okay. Thank you very much. I appreciate your time.